Hi there, welcome to the RPS project. Last time I had a quick look at turning on a transistor using a capacitor resistor sort of divider onto the base and just seeing how quickly or slowly it could turn that transistor on to the appropriate voltage needed for it to turn an LED on. Very simple stuff. I didn't do any maths, just wanted to see how it worked. But because of the resistance and capacitance that I was using, it was really quite quick. You didn't really get to see how much time it actually took until I got to quite a large resistance and quite a large capacitance. I think it was 1 mega ohm and a 1000 microfarad capacitor, whereas the much smaller resistance and capacitance values, you couldn't see it. So I did mention that I should really put it on the scope. So that's exactly what I've done. I've had a quick look at it on the scope and see how much time it actually takes to get to the appropriate voltage to turn on the transistor. So let's have a look at that. Okay, so I've got everything set up here on the bench. I've got my scope down here. I've got my board with my bits on, the little circuit set up. Now what I'm going to do is I'm going to have a quick look at some of the values. I'm not going to go through all of the values on this breadboard, just some of the ones in here with some of the capacitors. Otherwise I'll be here all day long trying to do this and set this up. So I'm going to look at some of the values. So let's start off with, well, I suppose the first one, which is a 100 ohm resistor and a 1 microfarad capacitor. So let's get this scope turned on and set up. Right, did I want it on AC or do I want it on DC? I think I want it on DC if I remember rightly. And I'm going to be taking a single shot at this. So power supply is on. I'm using 5 volts. So what have I got to do? I've got to set my, what's my menu trigger? Let's just turn that up a little bit so we can make sure we capture it hopefully. 100 millivolts. I'm on the leading slope, channel 1, single edge. Right, so if I'm going to put this on, and that's ready to go. So let's turn it on and see what happens. Well, hey, there we go, marvellous, it turned on. Now I can see that actually I'm not seeing much structure in that. Well, I am, because look, see, the whole thing when it turns on as I've seen is that it rises up and then it settled down at about the 1 volt, so we can see the whole process there. Switches on very quickly, runs up actually for quite a little bit of time before the voltage drops down and settles at that sort of 1 volt level. But what I want to see is this turn on time for the capacitor, so I can actually zoom that out and have a look at that and see what that time is. So if I just take that out just a little bit more, and then I'm going to measure that with the cursor. Let's turn it onto time, get that the way, and we have from the point where it starts to turn on till about there, which is where it finally settled at, because this bit's a slight overshoot, even though it stays there for quite some time before it settles down to its working voltage. I've got, well, according to this, about 20 microseconds. I mean, you could fiddle that slightly less, wrong one, slightly less, 19, 20 microseconds, something like that. And we are talking microseconds here. So that transistor turns on real quick, that little transistor that I've got in here, that 1 microfarad. So just turn that off, get it out of the way, and turn that off, and change and have a look at, say, I don't know, 100k resistor. So I'm just going to move the link to the 100k resistor, but with the 1 microfarad capacitor still. Let's just discharge that. Dropping my notes there. Right, so let's reset this back to the, where did we have it? 1 millisecond time base. So we're just going to reset that, and it's ready. So hit the on. Hey, now I need to change the time base, don't I, on this, because that time, even though it seems instant, is a lot less. So let's just turn that off, discharge this capacitor properly, and reset. Right, so the time base is now 10 milliseconds rather than 1 millisecond. Okay, so I've reset and I've now got that 100k and 1 microfarad in there, and on it go. Ooh, last a little bit of spiking in there. Didn't want to see that. Let's just try that again and see if I can get it a bit nicer, because that's not what I wanted really. So it's ready, and there we go. That's a bit nicer. So this time I'm on 100 microseconds on the time base. So let's just draw that out if I can. Sorry, other way. Getting a bit out of position here. Let's just center this trigger and move that across. So that's taken actually a lot longer. So let me just put the cursors on that and have a look at the actual time that it took. Move that to there. That's quite a nice ramp up. It's a very linear ramp for a capacitor charge, and about there, I suppose. That's taken me about 13 to 14 milliseconds. So we've gone from about 20 microseconds to about 14 milliseconds. That's a massive amount of time in increase in time from what it was before, because even though it still looks very similar, I know we can't see the drop down further on, but it's because we're looking at such a long period of time compared to the first setup of 100 ohms and on the 1 microfarad. We've got 10 millisecond time base compared to a 1 millisecond time base previously. So there you go. Very simple. Turn on the transistor, have a look at it on the scope, and as I could see from some of the notes that I'd made previously on testing this, that the smaller capacitance, the smaller the resistance, the quicker we get to the voltage that is required onto the base for that transistor to turn on. Trying to capture it on the scope though is a little bit tricky. Can be a little bit hard to get set up. I found setting up triggering on the scope does take a little bit of practice, and this is a perfect way to practice trying to get that capturing. So yeah, so there's another thing you could try in it. If you're trying to use your scope and you're trying to understand how to use it properly, especially when you're trying to get that single capture on a scope, then this is a good way to test that out. It's a very simple circuit, and it gives you the chance to fiddle around with your scope until you can really get used to understanding how to capture a single trigger on the scope, because yeah, I find it quite a bit fiddly. But anyway, besides the point, basic understanding is more resistance, more capacitance, the longer it takes, as it should do, because it's basic electronic, electronic basics, basic electronics. It's greater time to charge, less current, takes time to charge and get that transistor turned on. Simple stuff, but you know, I find it quite interesting to go through that process of working that out and understanding what was happening. Brilliant. Anyway, if you like this video, give me a thumbs up. If you didn't, you know what to do. Subscribe, and all comments are welcome. See you next time.